Practice 8.3 with narration this time, I hope. So number 1, below are the graphs of a standard normal distribution and a t-distribution with 3 degrees of freedom. Indicated, indicate which graph is which and explain how you know. So take that D off. The dotted graph would be the standard normal distribution. The solid graph would be the t-distribution with 3 degrees of freedom. So your normal distribution is going to level out closer to the x-axis or the horizontal axis, and it's going to have a higher peak than your t-distribution. So you'll see that the dotted graph does level off closer to the horizontal axis, and it is the highest peak if you look in the middle. The t-distribution with 3 degrees would be the solid line because the peak is lower when you look at it. You have a lower peak right here, and then the tails are actually higher than the normal distribution. Okay. As your sample size gets larger, your degrees of freedom also gets larger. So if you go up on to a higher degree of freedom, then you're actually getting closer and closer to the normal distribution. And so if you go lower and lower and lower on your sample size or on your degrees of freedom, then you're getting further and further away from your normal distribution. And so what you'll see is that as you have a smaller sample size or a smaller degree of freedom, your peak is going to start getting lower and lower and lower, and your tails are going to get higher and higher off of the horizontal axis. So for part B, it says on the same figure, sketch a graph of a t-distribution with only 1 degree of freedom. So when you're going from 3 degrees of freedom for the solid graph to 1 degree of freedom, you're going to see that your peak is going to be lower. You're getting away from the normal curve, and then your tail is going to be higher than both the normal curve and the t-distribution with 3 degrees of freedom, since your degrees of freedom is getting less. Number 2, find the critical t-star value for each of the following confidence intervals. On part A, they give us a 95 confidence interval with 8 degrees of freedom. So I'm going to go second vars. Let me back up a second and say, if you're kind of having trouble with what to put in the area, I know a lot of students are having a little bit of trouble with like how many decimal places should I have and stuff like that. So what you can do to be safe is just go 1 minus the confidence level, so 1 minus 0.95, get your answer, and then divide that by 2. Because remember, you're finding that 5% is left in the tails, but you have 2 tails and they are symmetric, so you'd have 2.5% on the left and 2.5% on the right. So I'm going to do my area as 0.025. So second vars, number 4, gets me the inverse t, and so I have 0.025 as my area. I have 8 as my degrees of freedom. They actually gave me the degrees of freedom, so I don't need to subtract 1. You only subtract 1 if they're giving you the sample size. Okay, so that's where I got the 2.306 from. For part B, the 80% confidence interval when n is equal to 20, I can do 1 minus 0.8 and then divide that by 2. So that tells me I have an area in the tail of 10% or 0.1. So I want to do the inverse norm. So second bar is number 4. My area is now 0.1. My degree of freedom is not 20 because that's the sample size. So remember that your degrees of freedom are going to be your sample size minus 1. So I'm actually going to do my DF as 19. And so that's where I got the 1.328. Okay, number 3. You want to estimate the mean fuel efficiency of Ford Focus automobiles with 99% confidence and a margin of error of no more than 1 mile per gallon. Preliminary data suggests that the standard deviation, and that's the standard deviation of the population, is equal to 2.4 miles per gallon. It's a reasonable estimate of the standard deviation for all cars of this make and model. How large a sample do you need? So I'm going to start off with the margin of error is equal to the critical value times the standard error. And in this situation, we actually do have the population standard deviation. So we will be using that within our standard deviation or standard error. So the margin of error that they want is 1, and that's a little confusing because a lot of times we'll say we want a margin of error of no more than 3%, and so within the problem we work that out with 0.03. But this 1 is not a percentage, so I'm not going to work it out as 0.01. I'm going to use 1 as my margin of error. My critical value is 2.576. Let me show you where that came from. If we have a 99% confidence level, we're going to do 1 minus 0.99. So there's 1% left for the tails to share. We're going to divide that by 2. And so the area that I should be putting in the calculator is going to be 0.005. For margin of error, like when you're, for solving for sample sizes, you're just going to use the Z star as your critical value. You're not going to be able to use a T star. Think about it. You couldn't find your T star as your critical value if you're solving for a sample size, because your n is unknown, and don't we get the degrees of freedom from our n? It's like the n minus 1. So it wouldn't make sense to try to use the T star as the critical value here. You wouldn't be able to do it. So I'm going to do second vars number 3. The area we just got was 0.005. And then leave your mean as 0 and your standard deviation as 1. And you do want to run it. And you will see the 2.576 as my critical value, my Z star. Okay, and then the standard deviation is going to be that population standard deviation divided by the square root of n. So really, this is not truly the standard deviation. This is like our adjusted standard deviation. Instead, it's really the population standard deviation divided by n. So that's where that comes from. And then I'm just solving for n. So what I did is I divided both sides by 2.576, and then I cross-multiplied. So 1 times square root of n just gives me square root of n, and then I'm not even going to work it out. I'm just going to write it down, 2.576 times 2.4. Why am I not working it out? Because I don't want to round. Rounding is bad. It'll lead us to the wrong answer. So to get n by itself here, you would square both sides. And so on the calculator, I'm just going to type in my critical value, my Z star, times my standard deviation, and then I am going to square it. And so that's going to give me not the right answer. What did I do wrong? Oh, wow, it's not 2.756, it's 2.576. The really funny thing is I did that on the original video as well. I'm recording this because my students let me know that in 6 periods a day that the narration wasn't working at all. So that's really funny that I made the exact same mistake the second go round in the video. So sorry about that. But now you can see where the 39 comes from, because you get 38.222. You always, for sample size 1, to round up. Because if you put in 38 as your sample size and you rerun this, you're barely going to be below, or actually you'll be right above the 1 mile per gallon for the margin of error, and so you'll miss it by just a hair, and you don't want to do that. So always round your sample size up. Okay, Polly's Pizza claims that the mean time it takes for them to deliver a pizza to dorms at Nat's College is 30 minutes. After a long wait one night, Nat decides to test his claim. He randomly selects 15 dormitory residents and asks them to record the time it takes for Polly's to deliver the next time they order pizza. Here are the results in minutes. The sample mean is X bar is 33.8 and the sample standard deviation is 7.72. Calculate and interpret the standard error of the mean for these data. So what you can do is, if they had not given you the X bar and the S, you can calculate it because they give you data. And I happen to already have it in my calculator since I did this previously. So I went in and I put all 15 of the data points in. So just typed in each one. You can see they're all there. And then I went stat over to calc, one variable stats, and I want to calculate it. And it's going to show me that X bar really is 33.8. Notice that we're using SX for the standard deviation, not sigma X. So we're using SX is 7.72. That is a sample standard deviation. We do not have the population standard deviation because this is only a sample of 15 deliveries. So it's not all of them, so you cannot, use the population standard deviation. You've got to use the sample one, okay? So saying all that, we're going to use the values they gave us, and we see now where they came from. To find the standard error, you do the sample standard deviation divided by the square root of n. So the sample standard deviation is 7.72. Our sample size is 15. And you just want to type that in the calculator and let the calculator handle it. So alpha y equals, I can get my fraction button, put my sample standard deviation on the top, which is 7.72. I want to do the square root of the sample size. Sample size was 15 different deliveries, and that's where the 1.993 came from. So that would be our standard error. It does say that we have to interpret it as well. So you have to start off by saying you have many samples of the same size. Remember that we do have to have the same size each time because we are using that 15 to find the standard error. So we can't change it each time. It's got to be consistent. So if we take many samples of the same size, and the difference between the sample pizza delivery mean and the population pizza delivery mean would be about 1.993. So the standard error is the difference between your sample mean and your population mean, and make sure you do bring it back to the context of the problem. And then part B from number 4 says construct and interpret a 90% confidence interval to estimate the mean delivery time. Does the data support Polly's claim? And use the 4-step process. I do give you a hint on the chapter test next time of when to use the 4-step process and when not to. By 4-step process, they just mean the state plan do conclude. And I want to remind you also that for plan, you have to do the conditions as well. So the way I kind of fixed it up for you on the chapter test, the chapter 8 test, is on the answer key, the free response questions that I want you to do the state plan do conclude on the 4-step process. I actually wrote, typed in state plan do conclude on the actual answer sheet. So you won't forget to do it. The only part I'm worried about you guys forgetting is on plan, make sure you do the conditions. List those 3 conditions that you have to meet, because I don't put conditions on there. But I do want you to know on the real AP exam, you're probably not going to be reminded, oh, this problem needs the 4-step plan. So you need to really, know when do I have to do that. And anytime it asks you to create or, construct a confidence interval, you're supposed to do the 4-step plan. Okay, so the state part is we want to construct a 90% confidence interval to estimate the true mean delivery time of Polly's Pizza. So you're really kind of just restating their sentence. You're plagiarizing. We are constructing a 90% confidence interval to estimate the mean delivery time. Like, you can write that as your state part. I went in and say for Polly's Pizza because that's bringing in the context a little bit better. The plan is that we're going to do a T interval on the calculator. We want to check the conditions that allow us to do that. We want to say that random is stated because he does say that he randomly selects 15. Okay, so 10%, we do assume that our sample size is 10% or less than our population. So we assume that Polly's Pizza does deliver more than 150 pizzas because we want 15 to be less than or equal, less than or equal to our entire population size. And then for the normal, we want N to be greater than or equal to 30. And guess what? It doesn't meet that. We only have a sample size of 15. So you'll notice I put a little X here. It doesn't meet it. So we have to look at a distribution. And when we look at the distribution that allows us to carry out the T interval anyway, even though we don't meet the 30, what we're looking at is in this distribution, is it extremely skewed? Like, do you have any extreme outliers? Is it strongly skewed to the right? Is it strongly skewed to the left? As long as it's doesn't have a strong skew and it doesn't have any extreme outliers, you can carry on and go ahead and do the T interval, even though we don't really meet the large sample rule. Okay, so what I did is I went into my calculator and I looked at the box and whisker plot. Because remember I said you cannot have strong skewness and you cannot have extreme outliers. So if I look at a box and whisker plot, I can choose the one that shows outliers. So when you go to type, make sure you choose the one that has the dots. Don't choose that one. That's not going to show if you have any outliers. You want to choose the one that has the dots, and then I'm going to zoom 9. Remember, I already have my data in the list. That's why it's going to allow me to graph this. And if you look at it, your whiskers are about the same length. So it is somewhat symmetric. It's not strongly skewed. I don't like the fact that the median is really kind of pulled to the right a little bit. But other than that, you do have some pretty decent symmetry going on. It's not strongly skewed. And then the other thing is we don't have any dots on the end, so we don't have any extreme outliers beyond our graph, okay? So it is okay because of this distribution, and you probably would want to give them a little sketch of that. You would show that, hey, I did look at the graph, and there are no extreme outliers. There is no strong skewness. Therefore, yeah, I can carry out. In the answer key, they always do a dot plot, and that would be fine as well. If you want to draw yourself a little dot plot or draw yourself a little histogram, you can see that it is somewhat symmetric. Let me look at the histogram. I'm just curious now what it kind of looks like. So again, I'm going to zoom 9 on the histogram. And so you do see that you don't really have a strong skew, and you don't seem to have any, extreme outliers. Even from the histogram, we can see that. So that would be another thing you could graph there to meet that condition, okay, since it does not meet the large sample condition. For the do part, I personally would just do it on the calculator. So I would go to stat, over to tests. I would be doing a T interval, which is number 8. You can do either one on this problem. You can do the data and have our data in list 1 and change your C level to 0.9. since it's wanting us to do a 90%, or since they gave us the stats, you can do the stats. So you can do 33.8 for the X-bar, 7.72 for the standard deviation, 15 for the sample size, and then again a 90% confidence level is 0.9. And so when you calculate it, you'll have the 30.289 and the 37.311. And then for the conclusion, that's where you write your interpretation of a confidence level or a confidence interval. So we'll start off the same way we always do. We are 90% confident that the interval from 30.289 to 37.311 minutes, because you want to bring it back to the context, minutes, captures the true mean delivery time of Polly's pizza. Okay. Normally we would stop there, but Part B actually asked us a question about the claim. So the next part says, does the data support Polly's claim? So our interval is 30.289 to 37.311. Polly's claim is that the mean time it takes for them to deliver pizzas is 30 minutes, and 30 minutes is not in our interval. So 90% of the time, we don't support his claim. Since 30 minutes is not in the interval, the data does not release the data that we have, the interval that we have does not support Polly's claim. If Polly's claim would have been 35 minutes, then we would say, yes, our interval supports his claim since 35 is within our interval. But it's not in there, so we don't support his claim. Hopefully this time the narration worked for you. We'll have to see.